Hello, everyone. The Ankido training team extends a warm welcome to you. We are thrilled to have you join us today for our webinar on machine learning methods in petroleum industry. My name is Mohammed, and I will be your host for this session. The webinar will be presented by our speaker, Mr. Hameed Mahmood Salih. Mr. Hameed Mahmood Saleh is a data consultant with a bachelor's degree in reservoir engineering from the University of Mosul, Iraq, 2018, and a master's degree in data science from IU International University of Applied Science, Germany, 2022. He has over 5 years of experience at the Iraqi Ministry of Oil, North Oil Company, specializing in reservoir engineering and production, as well as 8 years in the tech industry, focusing on software development, data science, and data engineering. His areas of expertise include data science, formation evaluation, reservoir modeling and management, data engineering, data analytics, geostatics, and machine learning. He is the founder of the SPE Mosul University chapter, co-founder of Mosul Space, a tech hub, and currently serves as tech lead at SPE Central Iraq. Before we begin, please note the following important points. If you have any questions during the presentation, please type them into the Q&A box and we will address them during the Q&A session at the end. Please be aware that this session is being recorded. Throughout the presentation, we will share links in the chat box that will enable you to connect with Enkido Training on LinkedIn, Facebook, WhatsApp, and YouTube. The link for the certificate registration form will be provided at the end of the presentation. Certificates will be issued based on the information received through this link only. Please join me in welcoming Mr. Hameed Mahmood Saleh. Mr. Hameed, please feel free to introduce yourself in detail. The floor is yours.
Thank you so much, Doctor. I am Hameed Mahmoud Salih. I have, as mentioned, from the Enkidu team, a lot of experience in both tech industry and petroleum industry. And that's what make the data science and the new machine learning methods. You can utilize it in your domain expertise. If you don't have a domain expertise beside your tech expertise, it will be lost. So that's the fantastic use of it when you have a domain expertise as a petroleum engineer or reservoir engineer or any kind of engineer or geologist, and you have the machine learning skills and data science skills, you can make the big benefit of it. So I have a long experience in the petroleum industry, the reservoir engineering, reservoir modeling, reservoir characterizations. I have worked on several projects utilizing machine learning algorithms and uh, data science tool in the petroleum industry. And also I have a good tech background working with integrated software and data solutions, data architecture, and the cloud computing. Today we are going to start our lecture, machine learning methods in the petroleum industry, and you are all welcome. The agenda for today, we are going to introduction to machine learning first and go quickly to the descriptive statistics and then the types of the machine learning, the regression analysis, classification, clustering, and time series forecasting. First, we start with the introduction. What is the machine learning? Machine learning is the science or scientific study of algorithms and statistical methods that computer systems use to perform a specific tasks without using explicit instruction. In the casual programming, we usually define the orders by conditions. If this happen, go do this. If this happen, go do this. But when we are using machine learning, we are using a subset of data called as a training data, and the algorithm define itself by using this data and take the decision automatically later based on the training phase. So this is the difference between casual programming and using machine learning. There is a very wide application of machine learning as we see today. Machine learning, data science, and AI, it is everywhere in our phones, in our computers, and the new generation of the large language model. Uh, Here we are listing some of the applications such as recognition, pattern recognition, face identification, emotion detection, handwriting, character and speech recognition, object of recognition objects in several disciplines such as medical images, as well as we can use it to borehole imaging, recognition of fractures, etc. Detection of motion in the videos and consequent images, recognition of unusual operations such as credit card transactions, sensors reading, engine sounds. All of these can be used in the petroleum industry in different departments. Prediction of future stock prices or currency exchanges. This is also similar to a prediction of the forecasting of the production and other parameters related to the petroleum industry and the production engineering, detection of fraud and spam filtering, establishing a recommendation system, grouping documents or image with similar content, dimensionality reduction. Yeah, and in the petroleum industry specifically, machine learning now is used with the seismic interpretation for more accurate, faster seismic interpretation, auto interpretation, and reservoir characterization and modeling in the many points in the reservoir characterization and formation evaluation, calculation of porosity, permeability, geostatistics, etc. And PVT modeling, decline curve analysis, drilling optimization, production optimization, petroleum economics, and other application. When you are working in the petroleum industry and you have a role of one of these roles you are working on, I think learning machine learning algorithms and skills is very important because you are having the domain knowledge, and this knowledge of machine learning help you to optimize your work and make the work more accurate. The life cycle of any machine learning project is starting by these steps. First, you need to understand well the question, meaning the question means the problem. You have to understand the problem well from business value, from the all aspects of, and goal of the project that you want to work on. The second phase is collecting the data about this question or about this problem. You need to know what the types of data you have, what the source of data you have, where this data come from, is it accurate or not? Do you need any other source of data that is not available? How could you make it available? Is this data available now and in the future? How about the privacy of this data and sharing policies? All of things that related to the data. After finishing these two steps, you will go to the exploring these data, making exploratory data analysis, understanding the patterns inside these data, and after that, you will decide which machine learning model or algorithm you are going to use that fit with your data and project goal. You select the model and then do training. And if your training accuracy is high and everything is well, you complete the project to provide the answer and deliver the outcome. If you have a problem with the modeling of the data, you didn't get the required accuracy, you could go back to step one, understand the question again, review it again, and go to follow the steps, collecting the data and exploring the data again until you reach the satisfying result. The types of machine learning they are mainly three types. The first one is the supervised learning. The supervised learning divided into classification and regression, meaning with the supervised learning that in the training phase, when you build the algorithm, you define the input and the output, and the algorithm will learn from the input and the output. It will be going into cycles. For this input, the output should be this. And for the unsupervised learning, you only define in the training phase the input, and the output automatically will be generated by the algorithms. The clustering method is related to the unsupervised learning. There is another type of machine learning, which is the reinforcement learning. This model usually used by games and auto learning systems. The working of this system is by taking an action and get reward for this action. If the action uh, is good enough, it will receive a reward of 90%. So the second action will be similar to the previous action. And if the rewards increased, that means the system is going on the right direction. If it is decreased, means the system is going in the wrong direction, and the algorithm will try to convert to another direction. So this is automatically learned. It is very helpful to use it in scenarios that the system need to learn by itself, or you define a system and it's going well and you face a rapid change that you cannot notice manually, and you make the system to modify itself with these changes. So we are going to go and dive further in each type of these machine learning algorithms in the supervised and unsupervised learning. We were not going to dive more in the reinforcement learning because it is advanced topic, and these other types is directly used and easily in the petroleum industry. This is the illustration and the difference between supervised and unsupervised. Here we have the supervised version. The input is apples, images of apples, and the annotation that we give the model. These are apples, and the output, the prediction, when it is work in the supervised learning, it will say for us that this is an apple, and if we input another type of a fruit, just like banana, the output will give us that this image is for banana and this image for apples. This is the supervised model. While in the unsupervised model, as you see here, we give a lot of pictures for different fruits. The model will classify similar fruit together, but the model doesn't know that this is apple or banana or anything else. It is only classify them together. And this is usually used in facies analysis. It is widely used in the petroleum industry. Here's the list of machine supervised learning methods. We have many of you have used or heard part of these algorithms and methods. We have the linear regression, we have the linear discriminant analysis, we have the logistic regression, we have naive Bayes classifier, we have multiple regression, we have the KNN classification, we have the SVM, support vector machines, decision tree, and assembly techniques. And for the unsupervised learning, we have the k-means clustering, we have the high dimensional clustering, we have hierarchical clustering, dimension prediction, principal component analysis. Before we dive with the uh, types of the machine learning, we are going to mention some topics that is generally important in the machine learning. One of these terms and subjects is the feature engineering. The feature engineering means building new features using existing dataset is known as feature engineering. For example, we have data to be input to the algorithm. The data is timestamp, means the date and time. And this data directly, if we use it in the algorithms, it will not be helpful. But by using feature engineering, we extract the month, we extract the week number in the year, we extract if this day is vacation or working day, we extract if this weekend or other weekday, we extract from the date the weather information, if it is the temperature, and if it is rainy day or any other information from the original information. This is the means of the concept of feature engineering. So feature engineering converts data that we already have, but we cannot use it directly in the model. We extract another data from it, and the extracted data, we use it then in the model. This is the example for the extracting variables from timestamp data. As I mentioned, uh, we can extract month, calendar week, day of the week, which quarter, which season, the bank or school holidays, special days, or religious or other events. I think it is clear for the featuring engineering. After we do the feature engineering, we extracted all of these data. We do another feature or another subject, which is feature selection. Now we have extracted, for example, 30 variables in the step of feature engineering. In the feature selecting, we are testing which of these variables is important for our model, and we use it in the model, and which of these variables is not important, having very low impact. So if we add it to the model, it only be noisy to the other variables. So this is what means by feature selections. There's several methods of testing the uh, importance of the features, sorry, and select them and use them in the modeling. Now we go to descriptive statistics. We are not going to deep dive in the descriptive statistic methods and how to calculate the each of them. We are going to go quickly. One of the parameters that is very important, and also it is used to determine if this variable important and selected for the modeling or not, it is the p-value. The p-value is a statistical measure to determine whether an effect is significant or not. Typically, effect for which p-value less than 0.05. We calculate the p-value for each variable, and if it is p-value less than 0.05, that means this variable is significant. If it is higher, it means that this variable is not significant. The p-value method is one of the values or methods that we use to measure if this variable is important or not, and use it for the modeling. Another important method to select if this variable is important or not is the correlation coefficient between variables. So the correlation coefficient, if it is near from zero, means there's no relationship between two variables, and we cannot model the relationship between these two variables. If it is reach from one or negative one, means that it is these two variables is completely matched, and there is a very strong relationship between them. So as we see here, we have a difference of these numbers of correlation coefficient, and we see the pattern of XY plot of these data. We see that when we have one, the data is similar to one line together. As we go from 1 to 0, we see how the data is scattered from each other, and the relationship is decreases until we reach the negative relationship in -1. And here we see that all of these types of a scatter plot that result in very low correlation coefficient. So now we took the p-value and correlation coefficient as basic methods for evaluating the variables that we use in the and include in the modeling. In the data types, we have two types of data. We have the qualitative data and the quantitative data. We have the qualitative data, which is attributes commonly contain quality, such as the gender, the color, the degree of satisfaction, is this is good, intermediate, bad, and these rankings. And the quantitative data, it is contain numerical data, such as weight, distance, age, and etc. This is an example of the qualitative and the quantitative data. Statistics is important in the machine learning because machine learning is field of intersecting between mathematics, statistics, and computer sciences. So statistics is one of the pillars of machine learning. The descriptive statistics containing several branch, which are listed below. It is the measure of center, measure of spread, measure of shape, and outlier detections. We are not going to dive more in each part of them and take each one how to calculate it and show the numerical methods and equations behind it. I think it is the basics of statistics and it is clear to most of you. Outliers, what means by outliers means we are facing usually in the petroleum industry that some of sensors maybe records very noisy, very wrong data points, and it is very, very away from the actual trend of the data. So this is what if we bring the data and directly input it to modeling, it will cause very noise in the output result. So this is what called outlier. As we see in this plot, this is single dot here. It is outlier, sorry. Uh, and we have to eliminate it. And we need also to understand the reason of outliers. And mostly it come from wrong from errors in recording the data from the sensors or manually or anything else. Yeah, so we have, before using this data to model it, we have to remove this outlier. There is several methods of dealing with outliers. We could replace the value of this by the average value of the remaining data or remove it or another methods. There is another advanced method to deal with it. So what I want to mention here is that outlier detection is important when working with machine learning. Now we have going to the regression analysis. We have mentioned the correlation coefficient in the slide before, and it is the measure of and degree of relationship between two variables. The value of correlation coefficient varies from +1 and -1. If it is reached to positive or -1, indicates a perfect degree of association between two variables. When it is reached 0, means there is no relationship completely between these two variables. And in the table below, there is an example of correlation coefficient between these four variables. So if you notice, the first one here, the this variable, when we make relationship with itself again, to same the variable in the horizontally and vertically, we got a complete match and the correlation coefficient is 1. Below it, when this variable sepal length with sepal width, it is only 10% in negative. So this is what means by relationship. And below it, the sepal length with petal length, It is 87%, which indicates a very good and high relationship. This is the correlation coefficient formula. It depends on the values of x and y and the distance equations between them. There is a lot of distance formula, just like linear distance, nonlinear distance, and at the end of the day, they are using the same concept to find the correlation coefficient between them. This is again an example of the plotting x and y in scatter plot and show uh, here it is a strong positive correlation strong positive correlation between x and y. Here is a moderate correlation, and here is no correlation. Here is curve linear correlation, and here is negative correlation, and this is moderate negative correlation. So when you see the scatter plot of the data, as you see there, you can detect the number of association between x, y, and detect number, sorry, of correlation coefficient between the variables. Now we have the correlation versus regression. In correlation, we measure only the relationship between the two variables, x and y, while in the regression, we are based on this correlation and this relationship. We make a future prediction of y by using x as an input. This is what means by regression. As written here, it indicates the significant relationship between dependent variable and independent variable. It indicates the strength of impact of multiple independent variable on dependent variable. We could use a relationship between x and y, single input as x, and the target is y. And we also can use multiple input as x1, x2, x3 as input, and the target is y. This is an example of simple linear regression. We have the data and the plot of it. We have the salary as a target in the column Y here, and we have the year of experience in the x-axis. So this is, if we see the dots, these are the actual data plot and show a good correlation coefficient. And now the line between them, it is the best fit line that across the points. This line have a formula. We will use it to predict the salary based on the years of experience. So in this formula, we enter only how many years of experience a person have, and it will result the expected salary for this person. So here is the formula y, and this is the slope of this line that best fit match between the points. It is 30.088. And another indicator here is the positive negative, the C, which is the intercept of the regression line with the y-axis. It is below the shape here. It results in negative 159. So this is what result from regression analysis. We could use y equal this number by x minus or this number, and we get y by only entering x. So this is the relationship between the ice cream cells and the temperature, weather temperature. So when temperature is high, the ice cream cells going to increase, and when it is low, it is going to decrease. And the R square here, it is coming from similar concept of the correlation coefficient. It is indicate the strong of this relationship. When R squares reach from 1, it means we have very high relationship and the accuracy of regression analysis is very high. When it is reached 0 or nearby 0 means the regression modeling is very bad and there is no strong relationship and no accurate result in this model. Here is more information about the R square. It is a statistical measure that represents the proportion of the variance for dependent variable that explained by independent variable or variables in regression model. So it is easily range from 0 to 1 when it reach 1 or reach 19, 0.9, 0.8, 0.7 means the relationship is good, the modeling is good, and the result is accurate. When it reached numbers nearby 0 means the relationship is so bad and the modeling is going to output with wrong results or inaccurate results. Now we are going to go with multiple linear regression. Multiple linear regression, same as the linear regression, but instead of we have only one input variable, we will have many input variables. So in this type of modeling, we will have x1, x2, x3, x4. In the petroleum industry, usually we use these methods. Let's say for formation evaluation, we want to find the porosity from density, neutron, and sonic together, and shell volume. We have all the inputs are density as x1, neutron as x2, shell volume as x3, neutron as x4, and the target is y, which is the porosity. So the formulation will be in this way. Y, let's imagine it as the porosity, and we have the intercept of the regression line, which will be positive or negative number. We have B, the density. We have, sorry, the x1, the density, let's say, by the slope of density line multiplied by it, a plus neutron x2 by multiplying by the slope of the neutron line, and etc. the shell volume and other variables. So we will using this formula by multiple input to find, for example, the porosity. In addition to the linear regression, we have many types of nonlinear formulas that when the relationship between two variables, it's not single one line simple. We have the exponential relationship, we have the logarithmic relationship, and another types of relationships. So these are also can be modeled and used, such as this is exponential relationship and using cosine and sine as a part of the relationship, which will convert it from considered as nonlinear relationship between the variables. There is another type of logistic regression. It is also considered as method for classification or logical gates. It is the logistic regression. The output of logistic regression is between 0 and 1, and it usually used as a good model for decision making. If it is reached 1, we go with positive value or positive decision, and it reach 0, we go with negative decision. Here is example and application of logistic regression application. We are predicting whether patient have a cancer or not. This is the logistic regression. We give a decision about it. Whether a customer will pay back loan or not, it is commonly used by banks. And whether an email is spam or not, it's also depend on this model. Or just make a prediction for student basic based on indicators that the student will pass the exam or fail. Until now, we have finished the introduction and we have finished the regression analysis, which is the first part that we took in the machine learning. Now we are going to move to the clustering, as it is the unsupervised learning method of machine learning. Here is another concept related to machine learning. When we are do training for data, we have these two terms, the overfitting and underfitting. It is important to consider these terms. What means by, if we notice the plots here, we have here the underfitting means that our model is not capturing the pattern of the data. So it is will result in very low accuracy in the training. This called underfitting. In the middle one, we have the appropriate fitting, or it is the good modeling. We see that we have the line have uh, captured most of the data, classifying most of the circle and axis, and the shape of the line is separating the plot into two areas logically. And this in this way we will get the accuracy of the model is high. And the overfitting, here's what the problem coming. In this, if we only indicate the statistical parameter in the overfitting, we will notice that we have, for example, 99% R square, which is very high. Statistical parameters indicate very high relationship, but actually the model is very overfitted and it is not will be that useful in a practical way. It will if the data changes in a production different from the training phase, it will go with very wrong decision or very wrong result. So this is the what means by sorry, the concept of overfitting and underfitting. We need to notice the how is the model is developed and how is it is plotted with the data. Sometimes the overfitting giving a fake uh, indicator that we are going in the right way. We give us very high statistical parameters, but the output result may be not good. Clustering, what means by clustering is to gather the data records into natural groups. And the clustering method is grouping our data in similarity. For examples, it is using in facial detections. It will classify the lithology into similar groups, and from another data, we already have, or we have core data that shown in this interval, this is a limestone, or this is interval is dolomite, or etc. We calibrate these similar groups and identify them. So it is very, very important. Also, it is used in and important in determining the permeability indicator zones and the channels in the lithology. Clustering is applied in many fields, including pattern recognition, image recognition, spatial data analysis, uh, bioinformatics, crime analysis. One of noteworthy area of clustering application is market segmentation, which is focusing on group market, grouping customers into different clusters and different characterization based on their attitude history. In clustering, there is many methods, but the main methods or most common methods and most used, the k-means clustering and the Gaussian mixture model clustering, GMM, hierarchical clustering, and density-based clustering. We are not having enough time to go for all of them one by one, but we are going to explore one of them. The k-mean clustering is one of the most used clustering method. It is a centroid-based clustering approach commonly used in practice. The method partitions data into number of groups. So when we want to use the k-mean clustering, before we start, we define the number of groups you want to use, and then let the algorithm work. So in this example, we have decide that we are going to classify our data into 3 groups. So as you see in this shape, we have C0, C1, and C2. In the initialization step of this algorithm, it will put C1, C2, and CO into randomly positions among the data. It could be here, 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 anywhere. And after that, it will measure the distance between C1 and the nearest point to it, this one, and this one, and this one, and this one, to the all points. And after that, it will relocate the position of C1 to the average of these points. Let's see in the following. This is the results. We have in the blue color, the old position of C1, and the new centroid is in the red one. So for cluster 1, the center moved from this position to this position and added all of these nearby the center points to it. What is make that it measure first if this point is nearby this center or by this center. If it for center 1 or center 2, if it is near to center 1, it will attach it to the cluster group of center 1, and then relocate the center based on these points that attach it to the cluster 1, and take the center of them, the average of the location of them, and move the center to it. The center will not move it from one step from this position to this position. It will, in many steps, take this from this place to this place, and then this place, and this place, then the final place, until you reach a step when you complete training or compute clustering. The centers will not change. When you reach this point, that means you have reached the final results. So if we go back, we see that these points are all same. We selected that we want to cluster into 3 groups, and the final result resulted into these 3 groups, 3 clusters. There is a limitation of this method. It is not suitable for very large data sets. When you have data with millions of records or many dimensions, this method will not be sufficiently efficient. And it is very, very simple and logical method, and could be significant in many use cases. And another limitation of this method, that the shape of these clusters is spherical or circular. So if the groups are intersected with each others, if these 2 points is related to another groups, but they are in this method, they will attach it to cluster 1 because it take just like center and circles. There is another method for that could be used for classification based on density, for example, or probability without this spherical attachment. As I mentioned, this is one of the most used and famous clustering method. We don't have enough time to go through the other methods, and now we are going to go with classifications. The classification, there is many methods of classifications, and these methods are commonly used, and one of them is the support vector machine. The SVM is very widely used. It is binary classifier, means it classify the data into two groups, yes or no, right or wrong, or something like this. And we have the decision tree. It is one of the most used model or algorithms in the machine learning ever. And we have the k-nearest classification, KNN. We are going to start with sub-vector machine. The support vector machine, it is built up on regression. It is similar to regression, but it is used in classification, not used for prediction. This approach is used widely in various domains that require high discrimination power. It is used in decision-making applications that require accurate classification and the prediction algorithms. One of the best of these things in this algorithm is can operate in both continuous and categorical data to classify them. And also it's can used in linear and nonlinear problems. As I mentioned, it is binary classifier, so the output will be one of two options, either yes or no, either strong or weak, either pass or fail, or anything else. This is how it is the support vector machine represented, or what is work. We have these two classes, the squares and circles, and we have this is the SVM line in the blue. It's separate between these points and these points, right? And we have the hyperplane lines. When we do training, we are trying to make the margin, the distance between this hyperplane, the upper one and the lower one, maximum. So we try different positions of the line until we reach the maximum margin distance between these hyperplanes. At this point, we reach the best for classification in the training, best result for the SVM training. And when we use the SVM in the classification, we will depend on this blue line, the SVM line. We will if there is a new point, if there is in the new point here, it will be classified for this group, the square group. If there is a new point here, it will be classified for this group, class A, the circle groups. So this is how the support vector machine works. In this way, while the training and after the training. As I mentioned here, mentioned that in the training, we are trying to find the maximum margin distance between the upper hyperplane and the lower hyperplane. And here is a 3D representation of how the line of the support vector machines shown in 3 dimensions. So it shows how it is separate blue balls from red balls. And know if there is any upcoming new point, it will belong to this group or this group. Here is an example between the show how we can create a support vector machine as linear model or as wavy model or nonlinear model that can capture the different pattern between these classes. This is all for the support vector machine. It is very, very simple and easy, but it is also very powerful and use it in different cases. We may use different of application that use support vector machine uh, in our most of the mobile applications and uh, internet tools. Now we have the decision tree. It is one of the most important in machine learning at all. Decision tree represent a group of classification techniques that are based on the construction of a tree, like a structure. This structure represents a set of nested decisions that make use of the provided feature information in a sequential manner to categorize the input objects. These classifiers are widely used in various fields such as image processing and character recognition. There's many applications in decision tree in different areas implementing classification, including medical, financial, astronomy, manufacturing, production, and molecular biology. Uh, the summary of this method that it is built a tree of decisions in sequence. So if you have the elements of this tree, it is the node and leaves. So in each node, you have a conditions. And if the conditions uh, have several leaf, and each leaf go with a different direction than other. So in this example, we have values in the node, for instance, minus 3, minus 2, and 4. And we have the decision if the value of f1 smaller than 0, it will go with C1 direction. If it is bigger than 0, will go with C2 direction. So these are classified. The minus 3 and minus 2 will go with C2, and the 4 will go with C1. And after that, it will be repeated. When it go with C1, it will face another node and another leaves until the end. So it could have many types of conditions. It could be numeric, it could be categorical, it could be uh, two decision or many decision, 3, 4, 5, depending on the scenario. So as you see here, we have these numbers, uh, less or more than 0. We have here based on color, it is red, will go with this direction, blue with this direction, and the green. And we have this is true or false classification. And as I mentioned, that the first node, and then leaves, and then the second node, and then leaves, and until we reach the final layer, and we end all the data with classification. There is a three famous algorithms used to make the core and calculation of decision tree. The most popular decision tree are ID3, which is started in 1986, and C4.5, which is used in 1993, and the CART method, which is used in 1984. Decision tree, when working on training the data, depend on something called entropy. It is the degree of disorganization and randomness in a set of the observations. So as you see in this uh, sketch, A is a completely heterogeneous. That means having the data belongs to two groups. and there is not it is not homogeneous, it's completely heterogeneous. And we have B, most of the data belong to one group, and we have only 2 points belong to another group. So this is uh, not completely poor, but it is good, less impure set. And we have the C, it is the completely homogeneous set, which have all the data points belong to one group. We are not going to dive deep in the H algorithms and talk about the calculations and how it works in the decision tree, but it is, as I mentioned, it is very, very important and one of the most famous and one of the best machine learning algorithms that give us very good accuracy. We can use it as uh, regression analysis. We can use it for classification analysis. We can use it sometimes for time series forecasting. It's have a lot of fields to be used in, and also it is very important in petroleum industry. It help to find very complex patterns between data and result with satisfying and good uh, accuracy. There is another method in the classification called k-nearest classification. The k-nearest classification algorithm, also known as KNN, it is non-parametric supervised learning classifier, uses proximity to make a classification or a prediction about the grouping of individual data. We in the clustering, we go through a method of similar to this method, but here we are going to use it again, but as a classification. In the clustering, uh, this similar method in the clustering, it doesn't know which class uh, is apple or banana or anything else. Here, in the classification, we are going to use the same concept, but we know which the labeling of each class, so we use it as a classification. So how it work? We have already this data is classified as class A and the class B. Okay. And we have this is in the purple color, a new data we want to classify it, right? In this method, we have to define the K number. If we have K number equals to 1, this point, the new one, will measure the nearest point to it, only one. So which one is the nearest one to this new point? If this one, so it belongs to class B. If this one, it will belong to class A, right? If we put the K to 2, it will try with two points. It will measure the nearest 2 points. This one and this one could be, and this one or this one could be. If there is 2 points from different classes, it will measure the distance, which one is nearest by it, and select and go to that class. If we have a 3, k equal 3, it will take the nearest 3 points to this point. So if we have this one and this one and this one, it will go to class B because two are from class B and only one from class A. So this is the concept of the KNN methodology. It's similar to the clustering, but here we have the data already is classified into groups, and we test the new data point belonging to each class based on the number of K. Based number of Ks means the nearest point to it, which is the identity of nearest point to it. We attach it to them. Until now, we are going through the most of the classification, clustering, and regression methods as machine learning method. These methods are simple and effective and mostly used. When we are going when we try these methods and we are not going with satisfying result, we go to the deep learning. Deep learning is more advanced and required a very big data to perform well. While machine learning algorithms, it could be work with very less data. It could be work with several data points to thousands to millions of data points. While deep learning method, which is depend on artificial neural network mostly, it required hundreds of thousands of data to start working and more. So that's make it very hard to use and very hard to get these data, especially in some cases of petroleum industry when data is expensive and we have a limited number of data, limited data sets. So machine learning is much preferred. The artificial neural network depends on these coming from this biological neurons and the perceptron. And we have here is the representative, mathematical representative of it. We have the x1, x2, x3, and each one multiplied by x by w, which means the weight of it. These weights will be changed during the training. Each cycle of training, a new values for weight will be changed until the algorithm reach a very good and satisfying result. And from this node, the coming weights and coming inputs from all of these will be result into 0 or 1 or number between 0 or 1. So we have the ANN, the artificial neural network. It could be, we have the input layer and output layer, and we have hidden layers. It could be 1 to 10 to thousands of layers. It is depend on how you design the artificial neural network and what is the purpose of this neural network. And there is also advanced designs that serve different purposes. So we are not going to dive deep into deep learning and neural networks. And this show a lot of types of famous uh, neural network structures, and each of them, each group of them, or each one of them have different use cases and have different use methodologies and different data, and could be used for clustering, for classification, for time series production, for either natural language processing, etc. Now we have the final subject for this webinar. It is the time series forecasting. It is very, very important and very important in the petroleum industry for forecasting parameters such as the production parameters, such as the production of oil, gas, and water. And it is the purpose of creating development scenarios. It's to forecasting what the performance of the oil field in the upcoming 10 years with different scenarios and etc. What is time series? Time series is a sequence of measurement over a time, usually obtained at equal space intervals, daily, monthly, quarterly, yearly. It could be in milliseconds, it could be in hours, depending on the source of the data and the method used to obtain it. Time series forecasting, it is a statistical technique used to predict the future value based on past observation in a time-ordered sequence. It is involves analyzing patterns, trends, and seasonality within historical data to make informed predictions about future behavior. The application of time series data, it is used in financial forecasting. It's very, very famous in financial forecasting, predicting stock prices, currency exchange rates, interest rates, and other financial indicators. It is also used in demand forecasting, such as you have a supermarket and you have forecasting that in these times of years you have very high demand on specific products and in others demand on and other times you have demand on other products and etc. So for products and services, optimize inventory management, production planning, supply chain logistics. This is crucial for retail, e-commerce, and manufacturing and distribution industry, sorry. Uh, it is also used in sales. It is estimating the future sales volume for businesses to set sales target, allocate resources, and plan marketing campaign effectively. And as I mentioned, it is very, very important in the reservoir management and production and forecasting and development scenarios of oil fields. It is also used in economic forecasting. It is used in energy, in the forecasting of electricity demand, renewable energy generation, weather forecasting, temperature change, precipitations, and extreme events. It is one of the must in the and used in almost all industries in the forecasting things related to times and events that expected to be happen in the future. Also, it have application in traffic management, marketing, and healthcare. When we come to time series forecasting methods, there is a different methods having different backgrounds. We can classify them into three main categories. We have the statistical methods that depend on simple statistical ways to to forecast the time series. And then we go to machine learning methods, and then we go to the deep learning methods. So we started in order, statistical method. It is easy to use and going with easy output, simple output, simple complexity. And we have the machine learning method. It is for more complex problem. You could use machine learning method. And also decision tree could be used here for time series forecasting. If we have very advanced problems, we go with deep learning methods. In the statistical method, we have these methods, moving average method, exponential smoothing method. We have the ARIMA. It is one of the famous method in the statistical method. This is commonly used by finance team, and it is widely used. You could search about it and you could implement it. It is easy to go with it. And vector auto regression method, the VAR. Uh, Before we go to the machine learning method, the moving average method depend on the averaging of the result. And for example, we take the average of last 5 days and we result the sixth day, and we take the last 4 days with the 6 days, we find the seventh date, and we go by this way. Using this method will give us a result, but we will going to lose the pattern of the time series. We're going to just like an average result. The machine learning methods, we have supervised model can be used for time series forecasting, such as linear regression. We have the random forest and XGBoost. The random forest is a group of decision trees, and the XGBoost is also a new algorithm that depend on the decision tree to find the time series forecasting. And with the deep learning methods, deep learning methods are a subset of machine learning methods that use artificial neural network to extract complex pattern from time series data. We use the recurrent neural network, RNN, and we use convolutional neural network, CNN, or temporal convolutional network, TCNs, and transformers. These methods of deep learning could be used to time series forecasting. So this flowchart show how is classified the statistical methods, the advanced method, separated into machine learning and deep learning. And each of them. The moving average method is a statistical technique used to smooth out of fluctuation in time series, as I mentioned. So if we have this points, this one is 1, this is 2, this is 3. And using moving average method, we want to predict this day 4 here. The moving average method, what we will do, we'll take these three values, 1 plus 2 plus 3, and divide them by 3, the number of them, it will result in 2. Okay? And if it will want to predict this one after this, it will take these three, last three, and then predict this and go it by this way until it reach the single value. It will not be changed. It is the average of the all. So it lose the pattern if there's a seasonality, and we go with moving average method for long period, it will lose the seasonality. So for this x, it will plus 2 plus 3 plus 2 and divide it by 3 and get the result. And for this one, it also will take these 3. Okay. The random forest method, it is a machine learning method based on the decision tree. Instead of taking only one decision tree, it will take many decision trees and make training to all of them together. And after the end of the result, it has a method to take best output from these decision trees and point it as the output of the forecasting. So as shown here, this random forest technique having 3 decision trees, 2 of these decision trees says that this object is an apple, and one of them says that this object is banana. So in this method, majority voting under this random forest, take the larger number of let's say trees that says this is same class. So it is the final class will be apple. So this random forest is also very famous. It depends on, instead of using only this one tree, it takes many trees, and at the end it will select the best result out of these trees. Until here, I have completed the material for this webinar. I hope it will be very helpful for you in your positions and in your jobs and in your week daily work. And I hope that I could see you again and talk more in the next opportunities. And I want to thank Ankido training team for organizing and hosting this event. And now we are open for questions. If we have any, you can send it through the chat box.
Okay, Mr. Hameed, thank you for your presentation on machine learning methods in oil or petroleum industry, and for joining Ankido Training's webinar series. I think you can see the some questions from our participants today. Please read them and answer them too.
Yes. Questions from Mr. Mazen. I guess all these methods applicable in Python. However, how can be benefits from ChatGPT? ChatGPT is very useful. It make individuals that understand the goal of their project or they know their problem well, use ChatGPT to create or generate a Python code that they can use it directly to get the output of the problem. If you have no coding background, no coding experience, but you have the knowledge in the specific machine learning algorithm or several machine learning algorithms and use how to deal with it, ChatGPT will fill this gap for you and give you the code with comments on it and learn you how to utilize and understand each part of this code. So I highly recommend using it uh, s- starting in the machine learning field, especially when you are in a situation you're facing a problem that could be solved by machine learning and you don't have a background in coding or Python. ChatGPT will be your assistant and it will do it safely. Uh, Try to understand and take your time with ChatGPT, asking him about everything you want to know about the code or about the algorithm. It is very, very helpful and make the work going much faster. And the second question, what best visualizing may recommend for use while logging data after machine learning analysis? Actually, there is different. You could use the Python itself. It has very good libraries for visualizing data. It could also use for visualizing log data. And if you work with a company that offer you a tick log or another commercial software, you could export the data in format that could be visualized in this commercial software, and you could see the data beside all the other data that already uh, have in your uh, commercial software and in your databases and system. So if you don't have these softwares, even if you have this software, I suggest that you start using Python libraries and visualize the data in Python and compare the output to the input result using Python, validate the result. And after that, if you want to use it in larger scale inside a bigger project, you can use what your company use as a commercial software. Where can we start if we want to learn machine learning for seismic interpretation? Uh, from Abdul Aziz Khalifa. Thanks for these questions. Dear Abdul Aziz, there is many uh, professional people in this industry that they are posting articles about this subject, and one of them have a very wonderful YouTube channel that explain these methods in seismic interpretation. You could search for these articles. You start knowing which machine learning algorithms that is mostly used and for what specific topic inside seismic interpretation they use it and how they utilize it. You can read further about it, and I am sure you will be getting the answers that you want, and you will be able by a very short time to also use these methods in your daily work in seismic interpretation. The RAM Jafar is a powerful visualization tool primarily used to understand and debug machine learning model. It is an integral part of the TensorFlow ecosystem. However, you can also use it with other frameworks like PyTorch. Actually, there's many libraries that could be used for data visualization, such as TensorFlow is used for building the algorithms. TensorFlows work with Python, so any library with Python, it could be work with it. But for visualization of the data, there is a techniques or methods called exploratory data analysis. It is part of the machine learning project, you could search for these techniques and use it. It help you to understand well your data and the patterns and the relationships between your data before deciding which machine learning algorithm or model or library to go with and complete your project. For David, how can we integrate pressure and temperature data in elastic and naturally fractured reservoir with machine learning methods? Uh, I think as I understand from you, you want to find a relationship between different parameters. You could try to explain the relationship between pressure and temperature in these reservoirs. You could compare between pressure and temperature, or you combine them and compare it to the another indicator or variables, and you use the regression analysis or classification method based on the goal and purpose you want to use. Uh, Rayban asking about neural network. Actually, neural network it is more complex than machine learning, and the training of it is more harder. It needs very big data, not like machine learning. Could be simpler or better using for entry level. There is a lot of types of neural networks. You can start with simple one. You can just try a simple problem that could be solved by regression by using three inputs and one output, and you try with simple neural network to and see the differences between these results. Uh, a lot of things to talk about in neural networks. It needs many lectures to dive deep in it. So you could uh, explore it yourself. You could ask ChatGPT about it. You could read articles or read books about it. And later, if we got a webinar or training about it, you can join us here or learn more about it. For Khalan Jalil asking best algorithm for classification. There is no best algorithm for something. It depends on your data and depend on your project, machine learning project goal. What is your problem? And the exploratory data analysis of your data. This decide the algorithm that you want to use. So it is several factors. If you want to know this well, you need to list all the classification methods, and you know the limitation and of each one, and then you understand your business problem and business value in the project. You understand your data, and that in that time you could decide. A shorter way to do this, you could explain your problem to ChatGPT and explain your data and ask him for suggestions, and he will throw a suggestions for you and mention the reason for this suggestion and limitation of each method. So that is the answer for your question. From Reem Ammar asking which machine learning can use in service production, facilities, design of them, and simulation. Uh, as I think you are mentioning a very major uh, project that combining a lot of steps and a lot of design a lot of facilities inside it. So in this way, you need to use a specific machine learning algorithm for each step inside your project of design. And for simulators, it needs complex mathematical representations that may use many methods inside it. So it is not uh, a straightforward problem to solve it with one model. Sometimes even in very simple problems, we use three or four models. The input of the first model going as the output of first model going as input to second model, and the output of second model goes as input to the third model, and then we get the final output that we could use in practice in the projects. So bigger projects need maybe a lot of steps, maybe a lot of different models, a lot of different calculations, and we may have scientific equations that we use inside it. Yeah, and this way.
Mr. Hamid, can you hear me, please?
Yes.
I think we have questions in the beginning of the webinar. You can find them in the beginning of chat box. Which machine learning system is the most used for IPR, VLP, and PVT curves generation?
Yes, I think uh, regression models could be used for this purpose of IPR, VLP, and PVT curve generations. Also, you could get uh, more advanced with examples about this equation. You could ask ChatGPT the same question and add to it, give me an example with mock data and uh, the supports Python code. It will give you an examples about using how to use regression analysis in the PVT and VLP and IPR and modeling it. There's advanced method inside regression analysis, and it could be completely match with these problems and solve it and model it best way.
Think there is two questions more after these questions, if you can see them.
Is there any application for seismic interpretation? I think we answered this. Yeah, before this. Can you tell us some information about steam generator boilers? Actually, I haven't worked with boilers. Yeah, I don't know. I don't understand what type of information you need about the boilers.
Okay,
Uh,
Mr. Hamid, I think you answered the questions and we can finish our webinar today. So, dear attendees, thank you for attending today's Enkido training session. We hope you found the content informative. We look forward to welcoming you to our future events. Mr. Hamid, the Enkido training team appreciates your efforts and your interesting presentation. Have a wonderful day and goodbye.
Thank you so much. And thank you for the attendees all for attending this session and looking forward meeting you again in the next opportunities.
Bye bye again.